Now let us discuss about the procedure of this method. Suppose we have a parameter, let's say efficiency of a certain device, which is dependent on three dependent variables, which are A, B and C. Now suppose our function looks like this: coefficient d times a to the power small a, capital B to the power small b, and capital C to the power small c. Now let us take logarithmics or natural logarithms both side. We get ln d plus a times ln a plus small b times ln b plus small c times ln c. Now let us define a function f dash such that natural logarithm of efficiency minus all these other parameters or terms, which are a ln a plus b ln b plus c ln c. Now again, for this method we will open up one more parameter, which is f, or a function which is equals to the summation of this whole term, and not only this term but the square of this whole term, like this. So in this way we are going to derive the steps for logarithmic version of the least square method. Now what we are going to do next is now we will find the point of inflation, or the minimum or maximum point, such that first we will take a derivative of f with respect to small a, and we'll put it equals to 0. It will give us summation of this term ln d. We have to find this term and we have to put it equals to 0. What we are going to get is 2 times, here there is a square, so after differentiating it 2 will come as a constant before this summation. So in the summation the term will remain as it is, minus b ln b minus c ln c ln d, and now we are going to multiply it by the derivative of this term, which is ln a. So being positive or negative, it's not going to affect our equation, and this is constant, so it can be taken in the RHS, and finally we are remained with this equation, which is ln eta into ln a minus a times ln a whole square minus b time ln b into ln a minus c time ln c into ln a minus ln d into ln a, which is equals to 0. So let us take this term on LHS and the remaining terms in the RHS. we get to ln A equals to A ln A whole square plus B ln B ln A minus C ln C ln A minus plus ln D ln A. Similarly, if we repeat this procedure for del F by del B, del F by del C and del F by del D, what we are going to get? We are going to get three equations which are in a similar way ln eta ln B equals to A ln A ln B plus B ln B whole square plus small c ln C ln B and the final term ln D and ln B. This one is the second equation. Earlier the equation was the first one. Third equation will be ln eta ln C equals to A ln A ln C plus B ln B ln C plus small c ln capital C whole square plus ln D ln C. The fourth equation will be because the ln D term will be converted to 1 in other terms, so only ln eta equals to A ln A plus B ln B plus C ln C plus ln D will remain as equation number 4. Now we are left with 4 equations and 4 variables A, B, C and D. And looking at the system of equations, we can easily find A, B, C and D. How? A, B, C, D, we have to put it in the matrix such that we get this equation. It's a very easy task from here. Just we have to use Microsoft Excel, use the data, find out all the summations and just put inside this matrix. Let me write the matrix. How does it look like? ln A, ln C, ln B, ln C, ln C whole square, ln D, ln C, ln A, ln B, ln C, and this one is 1. So the product of these two matrices will be equals to ln eta ln A ln eta ln B ln eta ln C ln eta. Now we have to solve this system of equations, or in short a matrix, for A, B, C and D. For that we can use Microsoft Excel. Let me show you that how we can use it. So see, this one is the data set in which we have four variables P, T, N and E, and we have written all these data points corresponding to each other. Now for the system of equations we need this kind of matrix. For that we need some kind of summations. Before moving ahead, I have to clear that these all things are summations, so don't confuse. All of them are summations, so you have to put it here also. Okay, so this was a constant, we don't need to put it there. And okay, right, now it's all right. So we have to follow it, and according to that we can see here I have taken the logarithmic terms of all these data points, then the required squares ln p square, ln t square and all, and their products. After all that I have taken the summation of all these here, and using these summations I have made a matrix of all these variables, and using the inverse of the matrix we have got the values of A, B and C here. So in our case we are going to have four variables. Here we are showing that, and you can use any number of variables. There are two variables, more than two, means 5, 10, 15, any number of variables you can take in this logarithmic least square method. So this was all about the logarithmic least square method. For any query, you can drop an email to me. Thank you.